Hi students, in this module we are going to discuss very important part of mathematics, that is functions. So in our previous modules we discussed about the sets and the main operation that is called as Cartesian product, and from the Cartesian product we discussed what is the meaning of the relation, and now this is a continuation of the relation. The name of the topic is functions. So now let me revise the topic what we learned previously. Set is a well-defined collection of objects, and the Cartesian product is the cross product of two sets A and B, and in A cross B we get all ordered pairs. We take a few number of ordered pairs, or we take all the ordered pairs we are getting from A cross B and say that as the relation R, and we discussed different types of relations in our previous modules. And now the next important topic, that is function, and it is also an operation or a rule which is associating the elements which are present in the set A and set B. Now let us explain that function with the help of some examples. Let us take set A is equal to set of 1, 2, 3, set B is equal to 4, 5, 6. When we find A cross B, we get total 9 elements because set A has total 3 elements, set B has total 3 elements. So number of elements in A cross B is already discussed, that is n of A into n of B. Here n of A is 3, so n of B is 3, n of A into n of B will be 3 3s are 9, total 9 elements will be there. We will take all the elements here. Here the first element 1 with the first element of the set B, that is 1, 4, next 1, 5, next 1, 6. So with the 1 we have made the association of the elements which are present in set B. Similarly with the second element 2. So 2, 4, 2, 5, 2, 6. Now let us take 3, 4, 3, 5, 3, 6. We have got total 9 elements in A cross B. Generally in relation we take all elements or a few number of elements from them. 1, 4, 1, 6, say 2, 5 and 3, 6 are the elements taken in the relation R. Now the same relation can be represented in the tree diagram. That means the pictorial representation of the relation. Here relation is represented with the two sets, say set A, set B. Remember, in relation R or in A cross B, whatever it may be, in the ordered pair the first element is taken from the first set and second element is taken from the second set. So here 1, 4, that means 1 is present in set A and 4 is present in set B. And next one 1, 6, so 6 is present in set B. And here 2 is present in set A and 3 is also present in set A. 1, 2, 3 are present in set A. And the elements present in set B are here 4, here 6, again here it is 5. Now from our relation R we can see that 1 has relation with 4 and 2 has relation with 5 and 3 has relation with 6. Now this is written as the relation in tree diagram form. Okay, now can we call this relation with the name function? Look here, number 1, 2, 3 are present in set A. So this set A is called as domain, and set B with the elements 4, 5, 6. So here set B is called as the range, because all these elements which are present in set B have the pre-images in set A. So the elements which are present in set A are called as pre-images. The elements which are present in set B are called as images, and set B is otherwise called as range, because here all these elements are having the pre-images. Set A is having elements 1, 2, 3, so that is called as domain. So A is domain, here this B is range, the B is also called as codomain. B is called as codomain and range. Now, what is the difference between codomain and range? Let us revise that idea. Codomain means the elements which are present in set B make codomain. That means a set of elements present in B. Whereas range, set of elements present in B which are associated with the elements of set A. Here all the elements which are present in set B are having association with the elements which are present in set A. Okay. Now we can call this as relation. Here codomain and range are equal. Now how we can call this relation with the name function? That's what we are going to discuss. Now let me take one relation R. R is equal to set of 1, 4, 1, 6, 2, 5, 3, 6. Now let us write it in the tree diagram form. Say this is set A. Here we have set B. Let me write all the first elements here. 1 and 2 are the first elements. Here 1, here 2 and again 3. 1, 2, 3 are the 3 elements which are present in set A. Now the elements present in set B are 4, 5, 6. Now let me make the relationship. Here 1 has the image 4, 1 has the relationship with the element 6, and 2 is making relationship with the 5, and 3 is making relationship with 6. Remember, this is a relation, whereas this is not a function. How it is not a function? That's what we are going to discuss. Here the element 1 has 2 images, so we can write 1 is related to 4, similarly 1 is related to 6. Let us take only these 2 elements for our consideration. Same pre-image is having 2 or many images. If in such cases we can call this cross product or the elements which are present in the ordered pairs with only the name relation, and it cannot be called as a function. So what is function? Function is a rule. Function is an operation which is making the relationship with the 2 different sets A and B with some conditions. Then what are the conditions here? The elements which are present in set A should have images in set B. That is the first condition. So whatever element you take in A, they must have the images. Let us check this case. Yes, 1 has the image 4, 1 has the image 6, 2 has the image 5, 3 has the image 6. Yes, first condition is satisfied here, but we are not calling this with the name function. So let us go to the second condition. As per the second condition, whatever the element present in set A should have only a unique element in set B. But here that condition is not satisfied, because 1 has relationship with the 4, 1 has relationship with the 6. So 1 has 2 images which is not accepted in functions. In function, the thing is every pre-image should have only 1 image. Every pre-images are taken in set A. All these elements are pre-images. Here we are having images. Every pre-image should have 1 image. Every pre-image should have only 1 image. If it is having 2 or 3 or more images, we cannot call that relation with the name functions. So as per the second condition, this is not a function. Okay. So for function, what is the main condition? Every pre-image should have only one image. Now we may get one more doubt, sir. Suppose here we have set A and B in such a way that 1, 2, 3 are the elements present in set A. Here 4 and 5 are there. If this is the condition, can we accept this as a function? Look at this figure. Here set A has elements 1, 2, 3. Set B has elements 4 and 5. 1 has image 4. 2 has image 4. 3 is also having image 4. So many pre-images are having only one image. Yes, that is acceptable. But if it is reverse, suppose if it is like this, here 1, 2, 3, 4, 5. If one pre-image is having many images, that will be considered only as function, a relation, not as a function. This is only a relation, but whereas this can be considered as a function, and this is also not a function. This is not a function. This is also not a function, but this is a function. So now we can come to the conclusion. What is a function? A function is an operation, or a function is a rule which is taken as f from A to B. We have to read it as f is a function from set A to set B, where A is the domain and B is the range, or B is having all the elements which are called as codomain. So here this case is a function. Clear? Now remember, the elements which are present in set A are called as, are making the, now here in this case set A has elements 1, 2, 3. So this set 1, 2, 3 is called as domain. In domain we are having all pre-images. And set 4, 5, this is codomain. Check it, 4 and 5 are the elements present in codomain, whereas only element 4 is having the relation with the elements present in set A. So this is called as range. Range and codomain are different, but range is the subset of codomain. So whatever elements present in codomain, they are present in set B, and range which is having the element which is present in same codomain itself. Clear? So now we have come to the conclusion that every function is a relation. Here this is a function. We can call this as a relation because we will get the ordered pair 1, 4, 2, 4, 3, 4. But whereas every relation is not a function. Every function is a relation, whereas every relation is not a function. So this is the conclusion we have got from this module. So in our next module, we will discuss what is bijective function, and later we will discuss about inverse function and other different types of functions. Thank you.